Welcome guys, welcome guys. Welcome to the stream. I hope you're doing good. Today it's holiday, so today we can go and do like long-term stream. So today I want to talk about graph neural network. So we are live, our audio is also fine. So yeah, that's good, that's good. So before, let me to do the announcement on Instagram. So I am back to Instagram. You can follow me if you want on Instagram. But I'm not sure definitely like what to expect from Instagram because it's changed a lot since I moved, and maybe there are some good people which can also come to our stream and get some benefit. I hope so. So, yep. So. Oh my god, how to take picture? How to take video? Like this? I see. I understood. It's first time. Like long. It was long since I didn't do it. Okay, welcome Instagram. So I'm streaming on YouTube. If you are free and if you want to learn about graph neural networks, please join the stream. So link will be in somewhere here. So join and we will rock and we will write the Python code on graph neural networks. So let's do it. Okay, welcome Instagram. So I'm streaming on. Then I need to add link. So how to add link? Maybe this one. Then I need to copy my link. Okay. Chat rate. So I'm streaming on YouTube. If you are okay, we are good to go. So what is graph neural networks? They are special neural networks. Let's say they are not. They works a little bit different because graph are combination of node and edges. So we need to investigate how does it work. So I think a good source to start is the Alexa. Okay, LLM, no. So graph neural networks are a family of neural networks that are dealing with signals defined over graph. Graph can model many interesting natural phenomena. So you will see them used everywhere, from computational biology, computational pharmacology, traffic forecasting, recommendation system. Oh, it's used on recommendation system. That's interesting, guys. That's interesting. That's interesting. Fake news detection. In recommendation system, we have rank. We have it was something like links and people, and we check the correlation. Interesting. Okay. I mean, let's not dive into the get, but let's try the simple GNN model. GCN, graph sage, pin sage, temporal graph networks. Temporal.
I want to make
2020. Shut. Maybe. Trust AGI. AGI. Oh, AGI. How can I disable this? Show icon and text. No. View. Hide third bar. Okay. Oh, graph neural networks was introduced something in 2009. It's too old. It's too old. It's recurrent graph neural networks and convolution graph neural networks. It's good thing to wear glasses because we will do long stream. This is GAN. Okay. This build on attention mechanism, and this build is on the convolution, and this build on recurrent neural networks. I see. Let's go with convolutional, and then simplifying graph convolution networks. Maybe this sounds very good. Let's go to code and let's go to the paper. Simplifying graph convolution networks. Open in preview. Preview is here, guys. Russ, can you turn off the fan? So graph neural networks and their variants have experienced significant attention and have become de facto. De facto is something from European, from Italian. De facto. It means default. Or Spanish or French. De facto. De facto methods for learning graph representations, GCNs, derive inspiration primarily from recent deep learning approaches and as a result may inherit unnecessary complexity and redundant computation. Unnecessary complexity and redundant computation. In this paper, we reduce this excess complexity through successive removing nonlinearity and collapsing weight matrices between consecutive layers. We theoretically analyze the resulting linear model and show that it corresponds to a fixed low-pass filter followed by a linear classifier. Notably, our experimentation evaluation demonstrate that those simplifications don't negatively impact accuracy in many downstream applications. Moreover, the resulting model scales to a larger dataset is naturally interpretable and yield up to order of magnitude speed up over fast GCN. Okay, So they did some kind of change on A model, and they make it like A version 1, adding some kind of functionality. So they said removing non-linearity, and collapsing weight matrices. And they're saying that it demonstrates like it doesn't negatively impact accuracy, and somehow it should like work. So they are making like change on A, and they are making A better. So let's check the what dataset they are using actually. Dataset. Let's check the dataset point. Spectral analysis. Oh no, we don't need this one. On citation networks and social networks, and then extend our empirical analysis to a wide range of downstream tasks. Okay. These citation networks, let's work on that. What is the size of the dataset? Citation network. Okay, ready dataset. Okay, they provide already. That's good. Which corresponds to public data splits due to space limit. Please download the Reddit dataset from fastcGNN and put Reddit H and Reddit NPZ under data. I don't have good like I'm using Mac OS, and as you know, it sucks. The memory sucks, the storage sucks. So I think the citation network is good place. Data. We can start with that. This is good mode. Good code. Downstream task. No. CGC. SGC. Normalization. Reddit. Tuning. Citation. What is license? MIT. Okay, good. Last time on Sunday, I was on in one friend's house, and then another friend of mine told me, Sardor, use agents, use these large language models, and you will see their power, and don't neglect their powers. And then I use them. They are good. But when they are fast also, but they are making me, I don't feel the adrenaline when I write and when I use them, because you have the fear that they don't write very well, and you need to debug them all time, and you need to be careful. So it means you need to know what to ask and what to you need to know their level of intelligence. It's limited, and you need to ask such questions, which will definitely save your time, but it will save your time, and they will work good, reliably. It will be like look up for API and make an example code, make an example simple Python code for something, or write some simple tests. Maybe it's good for them for doing like this stuff. Okay, let's fork this. So first Lego v1, and then data readme. Okay, نقش لي بشيك, and git status is ahead of origin. Okay, git push. Okay, now we need to get this link. Okay, we got it. and git clone, and let's go. Oh my god, why my screen is freezing? If you think that there's a problem with my screen, don't hesitate. Just ask and let me know. I will check it. Let me check actually the storage. Yes, the problem is with storage. I have limited space again. Okay, let me to quickly delete some stuffs from my computer. The weather is nice today, you know. It's very nice weather outside. It rained during at night, but now it's a bit cool and it is autumn, it is October. But weather is like calm, peaceful outside. You know, it's morning. What about if I delete this one? What is this? Oh, wait, guys, give me some seconds. Do you imagine that birds are singing outside? So good thing is go to with Tmax. And then, okay, we have Tmax, and then we go like this, we split, we need to split this guy, and then CD, SGC, and then LS. So in data, we have the data. Let's look to the data. I know it's citations, but how does it look like? I don't know. All X, all Y, graph, test, index, TX. What kind of this extensions in the PubMed? PubMed is the journal name, I know. PubMed, Quora. I think it's also, or maybe PubMed is not a journal. PubMed is a kind of hub, kind of platform. For some reason, I cannot delete my 2 files. Never mind, never mind, never mind. I don't know, there's some kind of problem. Maybe I need to go again to storage. Why I am learning GNN? I am learning GNN like because I have heard their power, like they are very promising according to people. So let's see how that's true. Why in developer we have 25 gigs? iOS developer? No, I'm not interested in iOS. Delete it. Okay, good. Now we have like 50? No. 45 gigs of memory. So in that case, if we will scale up, we will not freeze, and our screen is probably will not freeze again. If it freezes, then let me know, okay? So what we can do from this one? Let's read the citation.py. What is that? Citation.py. Okay, we import some libraries here. NumPy. Okay, we are using Torch. Utils. Okay, on utils we have the function load citations, precompute set seed, get model. Okay, model in the model makes sense. Metrics accuracy doesn't matter. Doesn't matter. One quick note is that perf counter is a good to like it is alternative to like it's good to use this instead of time.time. Better than using time.time. Perf counter. NumPy. Get citation arguments. So it means hyperparameters, maybe args. Pickle to load some Python serial file. Accuracy is a function. Get model is a function to get the model, to load the model. Load citations. Maybe it is kind of data loader or like data set of like Porsche data set. SGC. Set seed is to freeze to make it like to make sure that we can like reproduce. Optimizer F like for convenience. Torch we need it. NumPy manipulation. Argparse to use some command line interface. Time to measure time basically, but he's importing time twice. Look, it said if it is tuned and if arg model is that one, and we need to open this one to read tuning. Do I have that one? Okay, we have that one. And what's here? Oh, gem Cora. No. Cora. Weight decay. It's how is it implemented weight decay maybe. log of weight decay. Random seed, fine. Regression. Do you know what is regression, right? You know it, right? Regression is a task where a system or a machine need to predict continuous values. And it has no bounds. It has no like limits. It has no start and end. It is continuous. So train regressor. So this is function to perform training. Okay, we have epochs. Model.train 0 grad model and then cross entropy. Okay, they are using cross entropy here. Can we use cross entropy for making a regression? Okay, I don't know how that model works for sure. So we need to check. We have auto-regressive model, which are also regression, and they also use cross entropy. Then we are doing a backward and then step, and then we are checking the time to perform. Because graphs are very light compared to images, so they need to be trained quickly. They should be trained quickly. And then evaluate model.eval and then accuracy. Training time and accuracy and model. I mean, this is conventional way how people do. Nothing fancy, nothing special. But what is the output? That's my question. Output is what? Another citation? Output is what then? And what is the accuracy? So we are comparing label. Okay, it's train regression and then evaluate. Oh, simply that's it. Let's check it. What we will do? We need to use debugger. If we use debugger, we can like convert this Python code to kind of interactive session. Oh, we have model.png. This is model image. Okay, we have input graph and then feature propagation and then linear transformation and then non-linearity. What? And then prediction. Softmax. SH K minus 1 O input graph SGC logistic regression. This is conventional and this is what they introduced. I see. So you can see my screen, right, guys? No issue. Okay. So we are now in 35. No, 42. 42. So now let's continue. Oh, okay. On args.model we have nothing. We do have a model. Oh, it's very simple. Model is just a linear layer with 1433 inputs and 7 output. Oh, okay. What about what about args.epoch? Huh. Drop out. Why args is not working? Drop out. Oh, we have nothing here. Features. Okay, we have something on features. It's our data, and on features we can say indexed train. One hundred 1433, and then what? Labels. Let's check the labels. Three. Just numbers. What does a number represent? Okay, in order to know what number represent, we need to go to the numbers. And where is the features? Okay. And when we do load citations, we get the features and labels and etc. and etc. So let's go to that feature, load citations. Load citation is from utils. So let's go and open the utils. Okay. Okay. NumPy, SciPy. SciPy sparse. Sparse means sparse vector means a vector whose element is 0 mostly and non-zero. Like majority is 0, but minority is non-zero. We call it sparse. Sparse vector, sparse. Sparse, or like we like sparse metrics, sparse vectors because the computation is less, because any number which is not multiplied by 0 is 0. So you can go quicker and faster. I have seen this networks X for many times, but I have never gone and studied that one yet. Networks X. So I expect that it somehow helps you convert things into the graphs. And we have a normalization file, okay, and then we have a fetch normalization, row normalize. Okay, this is our main function. We have this x, y, tx, ty, all x, all y, and graph. We make an object and then we iterate through each file extension and then we open that one. If system version more than 3, okay. Wait. Objects will be what? List of items, right? And he's splitting everything in this order. And we say parse index file. And then test index range np.sort text index reorder. What is this? SP sparse Lille matrix. I don't know for sure. Is it good methodology to use this CUDA and then assign move everything to the CUDA memory from this place? I can't say anything for yet. So what I am not getting is that definitely we need to convert these citations into the metrics. Yes, it will be kind of graph, but like literally it should be metrics. I have some names, I don't know what they are, but then we read them and then we append them to the object and then we keep it in this order, okay? And if it is site seer, it has some special care, but generally what we will do is that we will vstack virtual. This is horizontal, and this is virtual. Vertical, not virtual, vertical. Vstack to Lille. What is Lille? To Lille. And then features test index reorder features that one. Agency metrics. I know what is agency metrics. Agency metrics. What was that? Agency. It was. I think it was something like like. If it is 0, it means there is no connection. If it is 1, it means there is a connection between nodes. There is edge. Represent edge. And then label is vstack all x on all y, and label text reorder equal to y text index range all per process citations edge normalize feature porting to PyTorch. Okay, porting to PyTorch. This is good command, Too dense. Float. I mean, there's many things I don't know. What is too dense mix exactly? And then load tensor. And we get the maximum from the labels according to the dimension 1 and get 1. 1 means indexes, or 1 means does it mean index or does it mean the actual value? 1. Or maybe it's just like second most facts, most maximum value. Sparse mx to Porch sparse tensor. I know what does this float do. I know if you use this float, your matrix or your scalar and etc. will convert into the torch float 32. Long tensor means float 64. But why he needs long? You know what is disadvantage of this long tensor? Because it takes more memory to use them. And like ideally the torch float 16 is better than torch float 32. So I have an idea. Let's go and debug this guy. For example, I will insert here import PDB and PDB. You know, we have like this directory has a git, and so we can mess up. We can do anything with this dataset, and then in the end, we can just convert it, or we can just commit, or just revert. And that's beauty of this git, you know. So I will show you git, okay? So for example, if I say git status, you know, I see the modified files and what happened to them. And then there are 2 files, but it's because of Vim. And then I can restore. I can say git restore and the file name and add file name, or I can make a commit. It's a good thing. So basically we didn't do anything special, but you can also get diff compare what's different. So now I need to run Python utils. Oh sure, definitely. Okay, I have a typo here. I think I'm slow, yeah? Am I right? I think I am slow. So now I want to say load torch not compiled with CUDA something. It doesn't matter. Oh, we got error. Why? if I call load citation, okay, we have error. It says please import SRX matrix from sparse. Okay, we need to search for it. Let me to modify that stuff quickly. SRX. $42. I mean, we are loading from the pickle. I can't do anything. Well, let me to say CUDA is false, and then try again. Okay, we are getting results. Okay, now it's working. Because I don't have a CUDA actually in my computer. So it's fixed, but actually it doesn't give me any privilege now. Load citation. Okay, let's go and read again. Okay, we have names. Okay, definitely. Okay, objects. Okay, it means we iterate through what? 1, 2, 3, 4, 5, 6, 7. From we iterate 7 times, and then we go and read. And system version info. Is it version which checks the Python version? Yes, it is Python version 3.11.6. Release level final serial 0. Okay. System. Interesting. I was thinking that system is operating system, but sys here is placed as a Python. It plays like Python interface. Okay, and then we go and say pickle dot load, say f, but we need to say Latin 1. Compressed sparse row sparse matrix of D type float 32 with 2, 6, 4, 7 stored elements and shape 141, 433. Oh, we just get it for granted. Okay. What happened? Okay. I shouldn't touch it. Can I say it like this? Okay, now x, y, tx, ty are each element of the list. Makes sense. And then parse index file. And then let's index file. Okay, it's in. They say it's index. Okay, it's just list. 1000. If datasets it's Cora vstack all x 1433 is what? 1433. What is that? TX. I think TX is a label kind of. No. And we say it's vstack. It means our features is that guy. Oh, okay. And now we have features. List of lists, sparse matrix of t-type. And that's all features. Okay, this is all features. It is all that training, all data or testing. So I see 1433 is repeating, like it was in our model, it was here, and I want to see, let's say, features dot 0. What list of list? Okay, then if it is list, show me list. Okay, we have coordinates and we have values. One, two, three, four, five, six, 7, 8, 9. Why 9? Why 9 elements? It means always we have 9 nodes, and value 1 means connected, but connected to what then? Like, I'm a bit confused. Let's make it quick, guys. Let's make it quick. 1, 2, 3, 4, 5, 6, 7. It's 7 here. And we got 7. I will try to figure out. But what is 1433? I mean, it should be the length of the vector, right? Length of the tensor. Okay. This feature comes from where? It comes from all x and tx. How I got this all x and tx? I got them from loading from the pickle. Who made the pickle? I don't know. I mean, need to check it. We need to check who made this one. For example, if we have the code, here it's good. Matrix tuning. Maybe it's in normalization. It's not here. I think good thing is just quickly go and check the on internet, you know. GTX 1080 Ti. It's his GPU name. And what kind of GPU I had? Do you know my GPU? I think it's raining again. It's good. Okay, this is what I am interested in, you know. It seems it so looks simple. Oh my god, this is very simple. This is what we need. This is what we need. Okay, maybe I understood here. Look. Index means ID for the paper, and this number is number of citations. So you can see it grows. For example, let's search for just number 1. Oh. No? Don't we have it? And Quora content. Maybe it's a text. Like. Oh. I don't get it. Let's investigate this guy also. Okay, okay. I think this makes sense than the previous one. But previous one, in terms of that, it makes this complicated. So here I understood. So here it means node number 0 and node number 19, they are connected. Node number 0 and node number 81 is connected. Node 0 and node 146 is connected. So you need to connect, okay? In your mind, it's connected. One means that it shows it's connected. And then what it will be is that node 0 and some nodes, they are connected. And what values they have inside? I don't see any values here. And then now we have 10 nodes here, right? 10 nodes go. I see there is no mini batch, right? I see in this in graph neural networks there is no mini batch iterating through the batch again and again. They are giving everything as once because they are light. They are very light. Okay, let me to bring some milk. Okay. Um, Load citation network dataset. Okay, we are getting the index features labels from content. Path. Okay. This is link to the content. And it loads from content. But I saw the inside, but it's like, you know, I think it shows whole connection. It means 31366. I think it is it should be number of citations, no? Three one three three six. 31336. Oh, okay. It can be. It is also it is also a ID. So I assume it's ID. And what about this, guys? And here neural networks. Done. And then we have another one. Rule learning. What is that? Probabilistic methods. Neural network. Case based. Neural network. Reinforcement learning. Wait. Theory. Maybe this is embedding. Okay, actually we load that one. Okay. Features. That's embedding. It is sparse matrix. You see it is 0 and 1. From 1 to -1, because you see in the end we have the string value and in the beginning we have an index. Kind of ID. So labels equal to, we take the last one, the word, and we say index feature label. Okay, and then we say encode one hot. Encode one hot means you need to represent it as 00001, right? For example, let's say if we have 10 labels, and then if we say encode this theory string, in that case theory string will be 1 and other will be 0. It's how one hot. Okay, then we say build graph. Index features label. 0 is index. Okay. And then what we are saying? Oh, it's not ID, it's index, some kind of index. And what we are using index for? So we say for I and j, for I is iteration number, and for j is is just once. Okay, okay, have a good day. Can you close the door, brother? Can you close this one properly? And can you close the door also? I mean half. See you at night. You will come back, right? I will come back. When? I will go earlier. I will go earlier. Okay, see you. So we build graph. Index features label 0 means okay. It will be list of items, list of indexes, and one of them is 59326. And then we are iterating. You are 1, you are 2, you are 3, you are 4, you are 5. And we have that map. Okay. And we say edge unordered. We go and read the citations. We say it integer 32. Okay. And we say edges index map.get. Okay, we are using mapping. Do you know how to use map? It's functional programming. Zip means combine. Map means I forgot map. I forgot. I used in interviews. They ask me a lot about this mapping. To understand this better, let me to show you the implementation of map. Like use case of map. Let's say I have a metric a vector a list 1 2 3 4 5, and I have a b. Make an iterator through computes the function using arguments from each of the iterables. For example, I have a function, okay? Let's make it simple function, which prints x, okay? Which prints I am called, okay? Oh. And then I say map fn. I don't call it here, I just give it function, and I give iterable means a, and that's map. And it is kind of generator, so I can use next. In that case, okay, I need to give one value because I am assigning one value. See? How map work? Okay, we have a function here, get. So this is, you know, this is dictionary, right? If you give the key, if you give the ID, I mean, if you give me this index from flattened, if you I take the ID from here and this iterable thing goes iterably to the get function, and this get function gets the edges and output I is the order, is enumerate, and I will be returned in place, and we will make it a list and we will make it as array, and then in the end we say edges unordered dot shape, reshape based on that shape. It's kind of we are uh, converting it into the ordered stuff just because to change the numbers indexes to make it to have small indices. Maybe that's the reason. Oh, hello, welcome, Harsh Realm. We are reading the implementation of graph convolution network. We want to understand about graph neural networks. Then basically we are just reading the source code now. And then we are using SP co matrix. Okay, now we have edges, right? Now we have edges, but now we need to show how these edges are connected, or do they have a connection? So in that case, we are using this adjacency matrix, and we use this SOAP matrix MP1s. Okay, this is 1, this is 2, shape. The type doesn't matter for now. Okay, we generate everything is 1. For everything is 1. Okay, it means like everything is connected to everything. We are using that stuff. And then edges all but 0. Edges all but 1. So here we create a matrix where everything is connected, everything is 1. Okay, and then agency plus agency t multiply agency t more than agency minus agency multiply agency t more than agency. We have agency, right? And then agency plus agency t multiply agency t multiply agency t more than agency. I don't get this one. Agency plus agency t. Okay, we change the dimension, change order of dimension, and then we say multiply agency dot t more than agency t means it will return the true false matrix. And if I say multiply t and true false is 0 and 1. So there will be no 0 because everything is 1. This doesn't make sense, kinda. And normalize, and then normalize this one. Like, what is normalize? Okay, it's here. Good. Normalize. We take sum based on the 1 dimension, and np dot power of row sum minus 1 Oh, minus 1 power. It means 1 divided row sum. And then we flatten them. And then R inf. NP is inf. R. Okay. We are replacing the infinities by 0. R met inf. R inf SP diagonal maybe, and mx equal to R mat inf dot mx and mx. So here the trick is that you normalize based on the first dimension. It means you normalize through the columns, and then for each column you divide by 1 divided by itself, the sum, 1 divided the sum, and then we just make it flatten. It's flattened already. Then if there is infinity values, we replace infinity values. Why occurs infinity level? Infinity values. So let me to prove. Oh, we don't have Python NumPy. Man. Okay, we have some problem. I will fix. So when I say Python, it works. But when I use IPython, it doesn't work. Interesting. Let me to do some push-ups, okay? Okay, good. Good. I found one very good good exercise. Like every 1 hour, you just go and do push-ups. And how much push-up is defined by you, based on your skills, based on your level. Okay, I have NumPy, so I want to prove you regarding the normalization, right? So let's say I have 1000 samples and my graph is 1443. Let's make it x. Okay. So that's our x. Okay. And then it is. I mean, it is. I want to make it unnormalize. So now it's like we have 12, minus 12, 10, 5, minus 12, 15, etc. So first thing what they are doing is that they said, okay, let's take the sum through the columns. So they say call sum equal to x dot sum 1. Then call sum shape should be what? Call sum shape should be 1443. Oh no, it's 1000. Wait. So we have 1443, then 1000 here. We can go like this and calculate for each row. In that case, it will be 1000. Or we can go and calculate the sum based on the each column. In that case, it will be 1443. So it means row because in NumPy, I mean, this is generally the problem. It always happen is that (1000 to 1443). It means this goes to the height. This goes to the width. Okay, I'm upset. Obsessed. Okay, so here mistake is that my mistake is that if I say sum 1, it means it takes sum from the dimension 1. It means it lets dimension 0 to be to remain. So it means row. In that case, row dot sum will be 1000. Okay. And then what we are saying is that we take that one and then we give the power. Why it's 464? So from minus 594, 591, we just get minus 0.00168. Yep. And why flatten? Flatten, I think, is not important. And here, when it comes to infinity, question is that because 1 divided by 0 makes error, right? So 1 divided what value can cause, so like minus something will cause infinity. Okay, infinity, what it will cause? I would say something is 0 is cause infinity problem, or nan value, or infinite value. I guess only these three things may cause problem. So how to prove, how to say, how to check, how to validate? In that case, in that case, in that case, in that case, in that case. What about if I say 1 divided by np dot array? We have 0. Okay, we got runtime warning, and we say we got infinity. If it's nan, then it will be nan, and if it will be inf, it will be inf. Oh no, it will be 0. Oh my god, 1 divided by infinity is equal to 0. 1 divided by infinite number, infinity, we get is 0. Because 1 divided 0 is infinity. And 1 divided by infinity is 0. Wow, beautiful. SP dx. Okay, SP dx need to have this value MP divided by, what is that? I forgot. X dot sum on diagonal sparse matrix of T type float 64. And we take the dot product from this guy and this guy. And dot product with X. So idea is here, we get the sum, and then we divide the sum, 1 divided by the sum, and then we just do some care about this one to avoid some nan values, and then we make a diagram based on this one. So it means R inf are very, very small numbers. If it is very small, it means very big, and if it is very big, it means very small power. And then we draw this sp.diax. sp.diax. Oh, number of diagonals. Okay, let's check this model. Let's check this repo. Okay, where I am. I mean, we can go just new. We can open new window and then we say git clone and then insert. Okay, I think there is nothing fancy here. We load the data, agency, features, label, index chain, index test, and then mm, number of features. It's important. It's not important. Not important. And then iterate through, and then we do just NLL means negative log likelihood is equivalent for log likelihood. An equivalent for cross entropy. Nothing fancy here. In utils we use everything. Oh, it's set. Based on set we return only once. Seems like. Okay, feature stores connection, right? Connection information. And where we are using feature. Feature is one here. It's here. So feature basically it is, you know, it's big sparse matrix now. And we make normalization and we get the features and done. So features is like combination of 0 and 1s. And then label is -1, last one. Means what? I mean, so encode one hot means okay, IDX features labels all -1 means it's big matrix of strings, and then I get this one and I say encode one hot and I will get a matrix of one hot encoded params. And then for example label X label 10 means special thing. It's not the order. Or maybe yeah, it might be the order also. So it's an encoder, encode one hot and labels. And then we say build a graph, index features label. 01 is the node ID, and then based on the node ID we paraphrase it. Why we are paraphrasing here? And then we have agency matrix, COO matrix, So let's read this CO. I close it, right? Sparse matrix. So it creates a sparse matrix. 1 till the minus 1. This big number, right? And then for each number, it gives something. It gives what is sparse. So I was asking about this one. It just shape 0. This one, and then okay, we got it. We have citations number, and so we have x. X is features. A features counts, and we produce a label. What is a label? I was thinking that this should be more interesting, but graphs are like, for now it's boring, or we are not getting something. Okay, we are using. Okay, we have a graph convolution and two of them, and just ReLU drop out. Okay, we have GC1 and then drop, and then ReLU, and then drop out, and then GC again, and then logs of max. So GC convolution, it inputs, it expect input of the feature matrix or feature vector, and it outputs the probability. No, graph convolution outputs another matrix. this is our forward important. So our input is feature. Okay, adjacency. Torch What does do? Multiply. mm. Perform matrix multiplication of matrix. So it does matrix multiplication. SPMM. Sparse MM. We have some some loading issues. I think it's because I need to add some init function, I have heard that I need to add init here. Oh, it has init. What is the issue? Utils. Okay, if it's in just utils, I will fix it. how can I change? Hmm. So graph convolution is just operation of and SPMM. Between its weight and input. Why not using dot product? Okay, here multiply means you just need to have identical matrix and then you can multiply. Element by multiplication, right? Element wise multiplication, and then we use agency and then support, and we do SPMM. I think we need to switch topic. I think you become tired. I also become tired of this one. In Torch, MMN are both functions used for matrix multiplication, but they are targeted matrix in use case. Let's check the torch mm and torch cmm. Ah, it's broken. What's x? Let's say torch dot random 102.443, okay? And then we have y. And it's also torch dot random, it is 104.43. And then I can say x dot y, but it will show me error because it doesn't match. But I can use torch dot mm dot xy, and it will show me what's the result? 104.443. Oh no. No, it's dot product, right? It's dot product. It makes sense. But if I make it dot c, in that case it will be 100 to 100. Okay. And SP is just fancy way of it. Not fancy way. SP is just optimized version of it for sparse metrics. And why he's not using just the, let's say, just dot product? Why he's using mm? So here, this is graph convolution, okay? So here we have input feature and output feature, and we make a weight based on the input feature and output feature. Okay. An extra parameter, yes. We are doing uniform. What is that? Okay, it's nothing, just, but we have a weight. It is 2D, and then we have adjacency. Adjacency is given, input is given. I mean, so Okay, this is graph neural networks. Okay, makes sense. Okay, that is graph neural networks. It means I can somehow represent the, let's say, face landmarks, or represent some kind of uh, logic. Let's say not logic, some kind of data or some kind of behavior in this way. It's it's similar to convolution. It's raining outside. Good, guys. I have so this is about about graphs. Okay, let me to answer. Another question comes. Yeah, yeah. So another question comes in my mind is that, okay, we have layers, we have model, we have train, right? So in the train, training is very quick, you know. Ha 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 ha. I know. So you need special care, right? Oh my god! Now I need to run. Minus 0.06 is closest. It's not beam. It's Vim. So I'm a bit confused about labeling. Okay, it is a label is a prediction of the next word of the word, and we got um, prediction of 0.00 minus 0.006, right? And if I look to the last one, and if I encode it, I see. No, no, it should be open source earlier. I mean, recently. What is this? Is it host on? No. Let's use perplexity. Perplexity. Search for recent news. Okay, now let's jump to something fascinating, something interesting. Yes. Yes, I'm talking about this one. 10 years. Bad website. Interesting. Okay, this is what they're using, and hmm. Interesting, interesting. Because yes, Twitter is important. Twitter is like X is important. It is. They want to really support the free speech. and I don't know exactly how it is, so we can now investigate. So it will be some kind of fun, because reading the graph neural network, and it is raining and it's peaceful here, and it is morning. I feel a bit sleepy here. I wonder, can I play music? I think I cannot play music, but can I play some poem? No. Okay, read me when it's changed last month. Okay. July 23. Actually, when Elon, and Twitter purchase 2022. Okay, it started on April 2022. He started to buy stocks, becomes the largest holder by April, and then to unite the joint board of directors and offer to join its board of directors, an offer he initially accepted before declining. On April 13, poison pill. Unanimously accepted. $44 billion. Ultimatum. Okay, he said it will be open source, combats spam bot accounts. It was popular as spam bot accounts and promotes free speech. Family acquisition is cornerstone of X. Then it should be started. Okay, 2020. Okay. 2023 on April it start to be open source. Good. We have all branches. We have only one branch, and then we have 3 contributors. Blogs. What is probability you will interact with another user in the future? Or Twitter, on Twitter, or what art? Hmm. Okay, recommendation is clear. Kind of clear. Okay, I need to register, right? Can I go without X? X.com. Let's say Elon. No, not Elon. X.com. Let's say Kaust. Okay, we can come here. Okay. We don't need to log in. Actually, what we have here, we have posts, we have replies, we have media, and we have icon mismatch. Here's the stuff. Let's say, for example, Omega Lab. Okay, it has following, followers. And let's check the developers. Developers thing. So inspect. See, it knows where I go. I went to Omega Lab, but here we don't have anything. It understands. There is no network request, nothing. Okay, here's something. Source. Let's go to elements, okay? That's head and this is body. What is this? Ah, there is some kind of buttons, but we don't see it. Okay, they're using this. What is this website? I don't know. I found Brave Search very fresh and very new. I think it's from their database, no? I mean, they have scripts which they download from GS. To log in from Google, log in from Apple. I mean, I like this X better than the Instagram and etc. Can I see followers? I think it doesn't allow. But it doesn't allow to go replies also. It doesn't allow to go highlights. It doesn't allow to go to media. Follow, no. I think no. It doesn't allow. It doesn't allow. Can I go to the here? Okay, I can go through the profiles. It's fine and good. Can I search? No. I understand. But one thing. Oh, what is this? One thing. What is that? Wait. Let's say site XCOM and say hacking. No. X.com. Let's say Elon Musk profile. See how DuckDuckGo sucks. Where they take this image from? Like, the image comes from here, right? Where is the link? I don't see any link here. Let me change the class name. let's say I will say it's here. Wait, link is here. So it should be on. So it should be on here. Elon Musk photo. Elon Musk photo. No. This is what is from. Okay, here. PBC. Okay, it's come from PBC Twins. Copy link. Let's check it. We can understand the backend of the system, but by doing like this. HTTP, we don't need this one. PPP, profile images. Profile images, let's keep it now. What's it like? Basically this one. Okay. Twim, PBC. Okay. If you ask the link, okay, it shows me. It shows me a link. Okay, it somehow got the link. Nobody knows how somehow. Again. What if I do something like this? Do I want to save? Actually, I don't want to save anything. How does it find this thing? It means their crawler is work so poor, or like their crawler are so good, so that I mean, I expect to have more of that thing, but we don't have more. It means it's not connected to that guy. And now let's use terminal, guys. Image not safe. GPG. Anyway, you know. There's nothing. Can I ping? Twitter image.com. profile images. And what is the inscription? 1749. I mean, this is host. Wait, I made a mistake. HTTPC, BBC, twim.com. Because when I downloaded it, it's nothing, you know. Delete. Okay, good. So actually, what we can do on Twitter? On Twitter. On X, it's X, guys. We have messaging on Instagram, on X. So let's check if we have the open source on that one. Oh, theft generator parser. What is this? Scala. I haven't heard about that. Seems like very old language, no? Nope. What protocol or ways does X use for its chatting messaging service inside? Is it secure and is it open source? Direct messages, they call it direct messages. Okay, that makes me kind of a bit uh, a bit thinking about, a bit worrying about this X, because indeed it can do man in the middle. When they wrote this, this makes it bad. I don't understand. Recommendation seems very good. My privacy close. It's useless. Scala. What is Scala? Okay, guys. We learned about the graph neural networks, graph convolutions. They are just simple thing. So let me to do push-ups. Let me do push-ups to get some energy. Okay. Good. Hmm. Nope. What's this one? Pinattara. I'm not understanding. Satoshi? Is it that Satoshi? No, he's another person. Scala is language now. Very simple. I see about you. Recommendation system is open source, but I see it has in network and out network stuff, and then what? They check my network. Yeah, in network and out, it's 50 by 50. It has some several models to like machine learning models to evaluate, to basically evaluate how relevant the post, the tweet. And I need to check about Telegram GitHub. Oh my god, it's so old. But it's premium. I mean, what is this? Advertisement just. It's not what I am looking for. GitHub. Uh-huh.
See, I
No. Yes, this looks safe. I mean, this is better than YouTube, maybe. It is dead. Let's go to Marshall. So because of this stuff, people are playing, like video, music on Telegram. So this is official implementation of Telegram call library. Last update is 2 months ago. We are in development. TQ desktop call. iOS. I don't know what is MM. But let's go to master. Master means main. Usually it says main, but it's 3 years ago. This is interface. So if you go to Darwin, party. I don't know this kind of stuff, but no. We are wasting time, guys. We are wasting time here. We are definitely wasting time. So, how does Telegram call work actually? It is you need to, so you press call button and it goes to the server, and from the server it goes to another person, and then my traffic, my package goes through server, or it goes directly to the user. I think it cannot go directly to user. Well, it's better if it goes directly to user, but I think now it goes to the Telegram server and encrypted form, and in encrypted form it goes from Telegram to the client, to the second person. I mean, how can I understand this framework better, this repository better? So wait, what is MT Proto? So MT Proto is special protocol, and it's people say Telegram say it says it's very safe. version 4.6. 8. Oh, set a fee. Oh, hello, hello. Okay, guys, let me to explain this one. So we will make a 256-bit package and send through the HTTP or HTTP or yeah, it's HTTP. Okay, we need to send it through this transportation layer. Okay, and 64, right? 64. It's 64, guys. I need this one. Okay. Proof MT Pro. CT proof MT Proto. And then look. I also don't know very well about this one, but we can prove, guys. We can prove by ourselves. We don't need any special hackers, any special people. So package, right? So we have a communication. So we have transportation layer, portation layer in the network, and it is maybe HTTP, HTTP. It's protocols, guys. Transportation protocols. It can be HTTP. It can be TCP. It can be UDP. something like that. Okay, transportation. So we have IP and TCP and IP and UDP. So this is transportation layer. Okay. HTTP is protocol, I would say. Transportation layer, UDP, and recently I have heard there is a new one also. I don't know that one. And then protocols are like SSH. Maybe protocols, maybe connection algorithm, SSH, HTTP, and then HTTPC, and then what? Simple mail transportation protocol, something like that, and more. Okay. So we talk through packaging. Okay, package and packaging. Okay. So in Telegram, we say they use algorithm name MT proto. So we have authentication key ID. It is 64-bit. Okay. And then we have message key 128-bit. And then we have encrypted data. You know what the 64-bit means, right? 64-bit means, look, 1 bit means 0 or 1. If it is 2-bit, it means 2 bits. Then it means 64 means 1, 2, 3, 4, 5, 6, 7 bits, and that 0 or 1 can change the itself. Okay, and done. That's it. 64. And here 1 to 8, it can go also like this, and then only 0 or 1, and then that is a bit number. Okay. Good question would be good question would be 64 is enough to have a unique authentication key ID. So here's a question: in how many unique numbers can we, how many unique key ID can we generate when we have 64 bits? Here's a question. An answer? How would you answer? So one idea is to find the one idea is to observe and to break down the problem to small pieces. So let's say if I have 1 bit, I have one value. No. If I have 1 bit, I have 2 values, right? It may be either 1 or 2. Okay, 2 values. If I have 2 bits, it means what? 4 values, right? So it means 0 0 0 1 1 0 1 1, right? Here 1 and 1. Okay. So you understand, right? You already figure out the pattern right here, and if you figure out the patterns, then congratulations, you are smart. So 3-bit means 8, right? 1, 2, 3, 4, 5, 6, 7, 8. It means now we observe the, we found the pattern here. It means 2 power 64. 2 power 64 is what? 2 power 64 equal 2 power 64 equal to this value. 9,000,000 3 milliard 4 billion, then what? After the billion, what? And then this one. How many devices do we have? How many accounts do we have? That's quite good. I mean, it feels safe to a certain extent. I don't know. Authentication key ID and message key ID. 1 to 8 bits. Message key means what? It means the it comes from what? Message key comes from what? CA1. Look. I mean, fine. We need to go down. Guys, if you have questions, ask. I'm happy to answer. So, client, right? I'm client, and there are billions of clients on Telegram. And we have salt. What is salt? I don't know. Move it. And then session ID. And then payload. What is payload? And why it's star here? Padding. So client always generates this thing when they send to the through the Telegram. When they send, when they post, when they call. Salt, I think it's something, but they are not disclosing it. Or I don't know. Session ID. So is value which is given by Telegram server when log in to the software, to the application first time. Salt. Okay, we have. 64-bit number. It isn't like timestamp. So it becomes a bit cold. I don't know. I have message key, but I don't know what is message ID. Okay. Payload is internal header and plus external header. No, it's not internal. It is external. Message and or external header. It's just fancy thing. we have Telegram client, and I can kind of check how internal cryptographics work. It means if I write a text, let's say, I say salam, and we will convert it into the numbers, right? So let's say it will be number 1, 2, 3, 4, 5. Okay, like let's say it's like converted to like in such a way, and then I convert it to the bytes, and it will be 0, 1, 1, 1, 1, 0, 1, 1, 2, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 0, 0, 1. Let's say this is what I got. Make it small, why big? And then this is our core message. I have a session session ID, session value, and it's also, let's say, 1111111, something like this, and I have a server. It means, does it mean each server has own salt, and it is possible to see the server person is connected to? I think Telegram has server in each country, but how to find it, I don't know yet. You know what I can do is that find the public IP reserved in South Korea by Telegram. Check it and do your best. Telegram has a server in each country to have stable connection. Oh my god. Interesting. Okay. We have server salt session and we have message. And they are all concatenated, right? I mean, they are all added or they are all concatenated. And I have a padding. $15 mean what? You mean 1 byte is 8 bits? It means 0 to 15. 0 to 8 4 to 100. So it means package has 120 plus 64 plus 64, 120 plus 128 equal to 248, 248. Okay. And usually we have 256, right? 256 minus 248 means 8 bits. Guys, here, look. I mean, our payload may be different, right? Maybe it is just one text, or maybe it is one paragraph, or it may be like constitution, very long text, and then we have a limit, right? Then we have a limit. So it means our package. So look. So from 256 is what we can send, I think. Minus 64 is salt. If it is concatenated, it doesn't make sense. I mean, if it's make the plus, it does make sense. How can we make it plus? Because it's bits. So it will be, of course, it will be concatenated. So then it minus 64 minus 64, and then we should remove the session ID, and then I mean, first 64 is for the salt, and then we have a session ID another 64, and then the remaining is 128. Okay, we remain 128 for core message. Okay, so core message can only be max length of 128 bits. Okay, and minimum length is, no, I mean, I would say not minimum length. We have maximum length. Minimum at least 8 bits always use. Let's convert the text, okay? I would say If I do bytes, it will go to bytes, right? UTF-8. From bytes to binary. Not in Telegram. What does this do? 08B. So it is what? 1, 2, 3, 4, 5, 6, 7, 8. 8 means what? 3-bit, okay? It's 3-bit. It is 8-bit. Oh, no, no, no. Ah, wait. Each character is 8-bit. No. Each character is 3-bit. Each character is 8 bits. Okay, each character is 8 bits. Each character is 8 bits, and we can only send at least one, and it makes sense. See, so then it means 8 bits. A single character or single encoded symbol. You know, and question is that we have 1 to 8, right? 1 to 8 divided by 8 means what? 1. 48 divided by 8, 6. 16 character. So it means 16 characters is the limit. Hello for 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Ah, we made one more. Okay, now. Yes. It means we only send, or we can only send 128 16 characters. Really? I mean, it is in previous, in proto v1. Okay, I think it was like before 2020, I think. Actually, it's not 64-bit. No, no, no. Maybe I'm wrong. I'm wrong. What is plain text? It's core text. What is that? CH? SH. SH1 hash function. Ah, secure hashing algorithm. It takes input, produce 160-bit hash value. It is not secure. Why? I don't know. I think I should have it. No, I mean decode. I don't mean encode. Hmm. I can just simply say from bit string import bit array. This is our bit, okay? This is our result. 162. 162 bits. One sixty. Yes, 40 to 162. First two things is ignored. And Telegram is using that thing, right? Simply speaking, Telegram is using that stuff. Interesting. But why are you updating it? I mean, now paddings is not 15 bytes, it is 124 bytes. In order to get authentication key, we need to send authentication key ID equal to 00000000000 and 0. I see. I mean, this is better than X, right? But how about the transformation of the images, etc., videos? Hmm, interesting. So there's so many things here in networking. Okay, here's voice call. Wow, so many information for today. Okay, I want to see in action. What is the Telegram client? Let's check the Telegram client. Okay, this is empty proto. This is how they communicate. This is all header. This is ID. Maybe this is ID. Oh, stress. Okay, guys, it is 11:30, 11:20. So thank you very much for watching. So what we did today, we did graph convolution networks. We read the code. We read two code. We run the code, and then we got bored, and then we went to X, and we studied about X briefly. That Elon acquired it in 2022, and then he made it open source most of part, but yet it is very, I don't think it's secure, and there are many backdoors maybe, or there are like stuffs. And then we studied about Telegram. Telegram has own protocol of communication. It's not I mean, it use HTTP, but it use, how can I say, special encryption, custom encryption. They call it MT Proto. And they had the version 1 and version 2, and recently they moved to version 2, and they are using version 2. So communication, both in secret chat, both in phone, in chat, everything goes through the server. But the point in secret chat is that this key, I mean the secret chat key, is not moved to the server, it stayed on the device. While the traditional ordinary, while by default on Telegram it is transmitted to the server. So it's like that, guys. Okay, guys, thank you very much. Have a good, nice day. Bye bye.